So my name is Michael Paquier, and I'm from France, currently based in Tokyo, working for a company called NTT. And today's presentation is focused on Postgres XC, which is a cluster solution based on PostgreSQL. Today's presentation will be focused on the core architecture of XC, its key algorithm. I will show a couple of HA features, and then the current status of the project. So just to try to see who people knows about XC, among you, how many people know about the name XC? Okay, thanks. Who has ever tried to use XC? Okay, you two, you don't count. Okay, so about Postgres XC, if you have any questions, don't hesitate to interrupt or stop me. I will be pleased to answer any questions. So XC has a project page located in SourceForge. From this page, you can access all the project manuals, install files, tables, if you want to get involved in the project. XC is called a Write scalable multimaster clustering solution for PostgreSQL. This name is kind of crazy if you are not very used to clustering solutions, so let's take it a little bit more simple. And let's say Postgres XC is called a symmetric cluster of PostgreSQL, meaning that there are basically no slaves and no master. All the nodes of the cluster are running with the same kind of status. You can do all the operations you want on each node, and each operation is immediately visible from one node to each node using global transparent transaction management. On each node, you can issue both read and write operations, and the architecture of Postgres XC is shared nothing, meaning that each node uses its own hardware, CPU, RAM, and so everything. Postgres XC is under PostgreSQL license, so you are free to use it, and it's more or less the same license as PostgreSQL. So about the core architecture of Postgres XC. First, let's make a comparison with the current PostgreSQL. In PostgreSQL 9.1, what you got with streaming replication and hot standby features is basically a single master and multiple slave configuration, meaning that you can issue read and write operations in the master, and those operations are immediately reflected in the slaves. Slaves can only receive read operations such as select queries or things like this. PostgreSQL 9.0 introduced the asynchronous mode of streaming replication, meaning that the slaves did not share the same timeline as the master, and 9.1 introduced a new major feature, which is the synchronous mode, meaning that all the nodes share the same timestamp view. So if you compare that with Postgres XC, what you get is that. So in XC, what you get is a series of nodes, and you can issue read and write operations on all the nodes as you wish, freely. In Postgres XC, data on tables is distributed or replicated among the nodes, and each node shares the same data consistency and transparency as much as the same timestamp view. So here are some scalability measurements we did with XC. Those measurements have been done with a benchmark called dbt1, which is based on TPC-W. The comparison is made with one single PostgreSQL server where we made dbt1 running, And we used numerous servers with XC in it, and what we observe, we made measurements up to 10 servers, and what we observe is a scalability up to 6. By scalability, I mean that we compared the amount of TPS, transactions per second, in a single PostgreSQL server with n Postgres XC nodes. So for 10 nodes, what we got is basically 6 times the throughput of a single server. Up to now, no questions? Okay. So I told before about the global transaction transparency management used in XC. What is used in XC is a kind of node called the GTM, which is called a Global Transaction Manager. This GTM is used to feed all the nodes of an XC cluster with transaction IDs. Transaction IDs, I'm sure most of you are very common with that, but basically when you launch one transaction, you associate to it a transaction ID. The GTM is also in charge of feeding other nodes in snapshots. Snapshots is the list of active transactions inside the cluster, more or less. And also to make all the nodes follow the same timeline, this GTM is in charge of feeding all the nodes with timestamp values based on the timeline of this GTM. Also, sequence values are taken directly from this GTM to ensure that sequence values are unique among all the nodes of this cluster. It's an important point, so if you have any questions, don't hesitate to stop me or... Okay. In XC, what you get is basically 2 types of nodes. One node is called the coordinator, which you can think about like a bridge between your data and external application. So when you use XC and you want to make your application running in this cluster, you have to make your application connecting with a normal, with the same more or less APIs or drivers as PostgreSQL to this coordinator. This coordinator holds some table information, such as the distribution key of a table, what kind of distribution the table is using, if the table is replicated, distributed, or anything like this. Also, this coordinator uses a connection pooling to allow this coordinator to contact each remote node with connections managed dynamically in this connection pooling. The second type of nodes in Postgres XC is called a data node. A data node is more or less like a normal PostgreSQL server. So it holds the data, and what we did inside it is we didn't really modify it so much compared to a normal PostgreSQL server, and it runs as a back-end node in the cluster. So what you get is a connection, an application connecting to your coordinator, and coordinator connects to the data nodes to get the data or anything you want. So it really runs like a normal PostgreSQL server. An important point between all the nodes in this cluster is that all the nodes share the same catalog information. This catalog information is synchronized. Yes? You can specify as many nodes as you want. Okay, there is a minimum of 2 nodes, 1 coordinator and 1 data node. But you can use n coordinators, m data nodes. It's up to the configuration of your application or anything like this. But yes, there is a minimum of 2 nodes, based on even 3 nodes, counting the GTM in charge of feeding the transaction IDs and snapshots and everything like this. So you get a minimum of 3 nodes based on that. Yes? The coordinator holds some, the coordinator is smart enough to choose the node where to locate the data based on the algorithm of the table. So the coordinator is in charge of that automatically. When, for instance, if you create a table on a certain distribution type, such as on a column or something like this, if you insert a value based, if you insert a tuple on this table, the coordinator will have a look at the value and will locate the data node where to insert the data in case your table is distributed. If it's replicated, you will send it to all the data nodes. Sorry?
Does the coordinator have to have that information?
Yeah, he needs. So, I mean, the distribution function is inside the coordinator, and the coordinator calculates that by itself. So.
Does it record that information and hold on to it or look up, or does it figure it out all over again?
It figures out all by itself. Yeah, by the way, I will give just after a couple of slides a small demonstration about how XC works, so you will see especially how it works, and at this moment also you can ask questions or anything like this, of course. Yeah, so it's based on an extension of create table that we just used especially for XC. Any other questions? Yeah.
On the tables that you define for distribution, right? You said you have distribution and replication tables.
Yeah.
If a node fails that has been defined as a distribution, does the entire table then become inaccessible?
I am coming to that just in a couple of slides in the part called the HA features. But you are true. If one of your nodes fails, you will lose all the data distributed on this node. Yes, that's true. But in order to prevent that, there are some techniques available. But I will come to this point just a little bit later. Okay, so here are the node types. So you got your cluster with here n coordinators and m data nodes. Your application is sending read-write transactions or anything to the coordinators as you wish. You can use a load balancing application or anything as you wish. The coordinator holds catalog information and a puller to connect to each node. You can't see so much the arrows here, but this is more or less basically how it works. A data node runs as a PostgreSQL instance holding the same catalog information as a coordinator and having the data in itself. An important point I forgot to tell about is that the code of XC is 100% based on PostgreSQL. So we took the PostgreSQL code and modified it to add a puller and to add a catalog management, especially for the table information and distributions or anything like this. So this is really if you have a look at the code of Postgres XC, you will see the same lock management, the same stuff. This is like a fork of the PostgreSQL Git repository. You could think about that like this. Okay. So let's go through the key algorithm of XC, how a transaction runs. And so a coordinator receives a query, which is a query string from an application, and requests immediately from the GTM a transaction ID and a snapshot. If you launch a begin query, you get immediately the JX ID and the snapshot. And of course, if you are inside the transaction, you don't request another snapshot or another JX ID. But if you are running in read committed isolation level, you request a snapshot each time it is necessary. So you get this information from GTM, snapshot, transaction ID, and timestamp to begin the transaction in the same timeline as in other nodes. So then what you do with this query string is the same kind of stuff as normal PostgreSQL. You go through a rewriter, an analyzer. We modify the analyzer and rewriter a little bit to stick with Postgres XC and the distribution information data of tables. And also you do some planning. Planning meaning that depending on the distribution type of the table, you send your query, or even sometimes you build local queries to be sent to each node based on the catalog information containing the distribution types and anything. Let's imagine that you want to select a replicated table and to perform a join on a replicated table or on a distributed table. The planner used in Postgres XC algorithm is enough smart to determine what kind of planning it can do to get the data from each node. So the planner sometimes can build local some queries for nodes to be run locally, close push down if necessary, such as group by, order by. We do also some aggregate push down. If you are looking for a max value, what you do is send the max value to each node, and then you gather the max of the max values on the coordinator. There are some stuff in this one. After the planning is done, what you get is some puller connections, and with those puller connections, you send query strings built inside the planning at the planning step at the data nodes. So you run queries on remote data nodes with the strings you built inside the coordinator, and with those queries you do like a normal PostgreSQL instance. You run those queries and you update the data of each node. If you perform an insert, this insert will be done on certain nodes. Then, if you do a select, you select the necessary information, and then you send back this information to the coordinator, and this coordinator materializes this information if necessary and send back this information to the client. Postgres XC uses the same interface as PostgreSQL, such as you can use normal PSQL terminal, you can use normal drivers, JDBC drivers, ODBC drivers, PHP applications. So this is the same interface as normal PostgreSQL, so you can run the same queries. Of course, we don't support all the functionalities of PostgreSQL, but we support a part of it. Yes, Stefan?
Question number one. When you're doing read-only queries, you still use transaction ID?
For the time being, yes. Even if this is not all the time necessary, yeah.
Second question. Are those data nodes, can they be regular Postgres instances, or do they have to be some kind of special Postgres XC thing?
For the time being, they have to be some kind of special Postgres XC thing. But just if you want to let me go to the next slide, this next slide is the demonstration of XC. I will show you what kind of behavior a data node also has when you directly connect to it and when you launch a query to it. So let's switch to that. On my local machine, I set up an environment with 2 coordinators, 2 data nodes, and a GTM. Also, as I don't want to cheat on you, I set up some port values. I think the screen resolution is a little bit low, so I can't show you the port values with a PS or something like this. But what you got to know is that for coordinator 1 and 2, I use the default port, and so this 5433 for coordinator 3, and for data nodes, such kind of stuff. So let me show you a little bit what XC can do. So here it is. So I got my coordinator 1 and my coordinator 2 ready to be connected with a normal PSQL. So let's go. And let's create first a couple of tables with different distribution types. So I'm on, let's do that on coordinator 1. Let's create first a table distributed. I mean, I really have some simple examples. And I distribute that by hashing using the column A. So here it is. I created a table on my coordinator 1, and what you could see is that if you do an anti/d, you get the list of relations inside your cluster, and magically, you get the table being created on the other instance. The DDL has been launched synchronously among all the nodes of the cluster. So let's create other types of tables, such as a replicated one. This one is called table rep, and I distribute it by replication. So here it is, by replication. I hope it's OK. Yes. No mistakes in the grammar. So this table has been created by replication. And let's create another type, distribution by round robin, with a table called table round robin, with the same kind of types. Round robin. To make things a little bit difficult, let's create a temporary table. So temporary tables are associated to a session. So if I create this one, you can see the list of 3 tables being created on coordinator 1, with my temporary table being using a round robin distribution. And if I got the same look here, of course I got 2 tables. This temporary one is not here, so this is protected. Let's do a couple of insert queries. OK, let's go from coordinator 2. In the distributed table, I mean, I'm really taking some simple examples. So here it is. I do this insert. Insert is done. Let's do the same thing for the replicated table, which is not temporary. Yes. And let's do the same thing once again for the round robin table. OK, so here we go. So, OK, but now you are telling me, how can I prove that the data has been well distributed among all the nodes? We created a new kind of query inside XC, which is called execute direct, which permits to launch directly to a node a query you wish. So let's launch an execute direct on node number 1. And let's check if the data has been well distributed for a certain table. So let's check that for oh yeah, true, node 1, from the table round robin. So on node 1, you got only the second tuple being located for the table round robin, and if you do the same check for the node 2, for node 2, you see that the other data, okay, you can't see everything, but you got a 1, 1 and a 3, 3. So the data is distributed among each node. Let's do the same check for a replicated table. On node 2, the table is replicated, so you get the same data on each node. First, this one. So on node 2, you get the data completely located, completely used for the replicated table. And if you do the same check on node 1, the table is replicated among all the nodes, so you get the same data. Then let's check if the data is also visible from the other instance. Let's do a select on the distributed table. And all the data also can be seen from the second instance. Also, before I was talking about using sequences in the cluster. So let's create a small sequence, such as foo. The sequence is created. Also, on the second coordinator, so if I check the data of this sequence, yeah, it is created also on the second one. If you select the next value of a sequence, you got a value 1 or 2, as you wish. And if you do the same one, we should have now 4, and what you got, the next value is 4 and 5 and everything you can do. So now to answer the question of Stefan before, let's check what is happening if you connect directly to a data node. I said before that a data node runs as a PostgreSQL instance, so it should run more or less as a PostgreSQL instance. I really say more or less. It's not completely the same stuff, but so let's check for data node 1. The port number is 15432, and I connect to it. Let's call that data node 1. And let's perform a check on, I don't know. Stefan, what kind of data do you want to see?
Where I was really going with that, to be honest with you, was I understand that there are certain limitations on
Yeah.
the XC side. I'm wondering if I want to get to the direct data node, could I avoid some of those limitations? For example, if you don't support windowing functions through the cluster,
Yeah.
could I do it directly on the data node instead?
For the time being, we don't support any window and cluster functions, so I don't know. I've never tried myself on XC, so it may be interesting to test through that. But by that, my point was that if you try to launch directly a query on a data node, what happens is that, from table, okay, this was a temporary table, so it's not going to work. Okay, so let's do that on the distributed table. And also, yeah, it also appeared before. So the data on this node is appearing, but what is happening is that data node is not allowed to get directly a global snapshot from the GTM. So you get a warning telling you you don't have a snapshot, so the data visibility and consistency is not fully protected in this case. Don't even imagine try to do DML stuff such as update, insert. This is the best way to break the data of your cluster. I mean, of course I tried, and I'm pretty sure you know what happens if you commit twice the same transaction ID in a PostgreSQL cluster, and the same thing will happen. I mean, if you commit twice that, your node is instantly crashing and, okay, it's done, it's over, it's a fatal. So here it is. And let's continue a little bit about the presentation in itself. Okay. So I know I'm a little bit long and you guys are looking for the weekend. So I hope still to take something like 20 minutes for the end of the presentation. So let's move next to the next part about high availability. I had a question before about, okay, but if one of your nodes fail, such as crashing, you got a server which is down, your disk is down, or I don't know what, so many things can appear in a server that you don't really know what can matter. So let's talk a little bit about that. You got two cases. As you told before, a data node is in itself a single point of failure if it contains data of a distributed table. Now XC has a limitation saying that when you create a table and you distribute a table on a certain way, this data is distributed on all the data nodes. We are currently working on a feature allowing you to distribute data only on a subset of nodes. This is currently being done. But for the time being, if one of the your data node is out, your cluster is out. This is the same case for GTM. GTM is in charge of feeding transaction IDs, snapshots, timestamps. So it's, I would say, the most important node in the cluster. So if this one is down, just say goodbye to your cluster. Yes?
Like wall shipping capabilities or anything to set up like a off the GTM, have everything GTM is doing wall, and then that way you could bring up a second GTM?
There is no such mechanism, but we got another solution.
Okay. Yeah. Well, we are doing the test and we also we found that synchronous for what we do well with this mechanism. So what we have to do like replication or we even for candidate because we have to work but as a mechanism yeah we do have that and also now we have a backup
So as you can see, there are more or less two cases where your cluster can be down easily. So looking like that, XC is really a fragile cluster. But there are ways to avoid that. The first one, let's talk about the data node SPOF. In this case, we got currently in XC the code being merged with PostgreSQL 9.1. So why not using synchronous streaming replication? So you have your cluster nodes, you got a data node. So use this data node being used as a master and put just related to this one a slave node running. As you could see in your cluster, you have a lot of coordinators, but coordinators hold the same data. So you don't really care if you lose one. You still have a lot of access points if you wish. But the key point is to keep alive the data inside a data node master. So use a log shipping mechanism with a synchronous streaming replication and a slave, and your data is safe. I made a couple of tests with after merging the code with 9.1, and I did a little bit of failover and things like this, and I saw things running nicely, of course. It was nice to see that running. XC does not have any internal mechanism for failover or fallback, so you may need an external monitoring application to do that, but I think it's like PostgreSQL. PostgreSQL also has no such features, so as a core, XC does not support that directly. Any questions on that? Okay, so you got a coordinator, a data node master, a slave running on that, being synchronized with a log shipping mechanism and a world sender. So I would say that even if this node dies, you could still fail over on this one. This is what is happening here. So something very, very bad happened on your server, let's say an explosion. And so, I don't know, I mean, I chose the flames, but I mean, an explosion is very spectacular, so let's think about that. So, it's an immediate disaster in your cluster, your coordinator is out, your data node is out, but you still have your slave node having all the data that can be fallbacked using a failover. And after that, if you change the port number of this node to be the same as the one before, you can still continue to use your cluster as before. So let's talk a little bit more about now the second case of single point of failure, which is the GTM. Koichi, who is here, is currently implementing a solution called the GTM standby. There has been some code committed in 0.9.5 of XC with a GTM standby, which basically takes some backup from the GTM each time you take a transaction ID. For a snapshot, it is not really necessary, but transaction ID, sequence values, and also we get in GTM some stuff to register nodes connecting into the cluster. So everything is backed up in this one. GTM standby is not completely functional for the time being. One of its limitations is that GTM standby is not guaranteed to protect completely the GTM data if you run several sessions in parallel. But this is planned to be done by the end of the year. So we expect to have a fully functional GTM standby ready for not the next release of this month, but the release after. So in case if your GTM fails, what you can do is an online reconnection to connect all the nodes back to the GTM, and you will get fresh transaction IDs, normal snapshot data, done with that. For the time being, online reconnection is used through a special mechanism. Yes?
I was going to ask, is there a mechanism to allow you to kind of proactively do that? Where you can just kind of say, say over to this other GTM, that way I can take the master offline or whatever?
We got some mechanism, yes, to be able to signal one process to do an online reconnection to the GTM. Indeed, I'm going to switch to the last one. Okay. In case if you got a GTM dead and you want to switch back, we implemented what is called a GTM proxy, which is in charge of grouping messages between nodes and coordinator, such as grouping transaction ID, snapshot stuff, for sessions. And what we do for the time being is sending a signal to this GTM proxy, which is in charge to reconnect to the GTM standby correctly. So by special mechanism, this is what we have for the time being. For the time being, nodes cannot reconnect directly to a GTM standby after a GTM crashed. So this is our solution for the time being.
The thing about this mechanism is that the coordinator or data node does not even know that the GTM standby has total and also, and we don't have to give us any random standard. And also, if you don't have GTM standby and this GTM standby, well, for time being, for cluster system, that you can start new GTM from the cluster and give it what needs like cluster. So we're going to give up all the clusters here first.
Okay, so here is about the GTM single point of failure resolution. We got also some additional stuff to support point-in-time recovery in a cluster. You know that now in PostgreSQL, when you want to do a point-in-time recovery, you have to target a certain transaction ID a certain timestamp, but as nodes are located on different servers, if we point to one if we point to one moment in the past, we are not sure if this point-in-time recovery will be done consistently in the whole cluster. Let's imagine, for instance, here we got a simple cluster with 2 coordinators and 2 data nodes. This one is the timeline of each node. So you are doing some point-in-time recovery, let's say consistently, magically, I say for the moment. And I mean, this is just to explain that. So you need consistent points to restore to a point in the past. Imagine that you get one of your data nodes failing at a moment, and you need to go back to a certain point in the past. You need to roll back the whole database consistently, and we implemented a special mechanism to protect that in a cluster way. So for PITR, the transaction status has to be consistent in the whole cluster. When you do write transactions among several nodes, you need 2PC to commit the transaction correctly. So if you use 2PC, the risk with that is to have a transaction partially prepared, partially committed, or even partially rollbacked on a part of the cluster. If this happens, your cluster is in a bad shape. So you could use PITR, point-in-time recovery, to go back to a past state where this was okay. So yeah, so for 2PC, we have to avoid the case where a transaction is prepared or committed partially. We need a transaction status being the same among the whole cluster. And so what we do is writing in each wall of each node of the cluster a consistent record called a barrier, which says that if we do a recovery up to this barrier point, we will get our whole database being recovered at a consistent point. So this barrier mechanism waits that partially committed or aborted transactions commit, such as you don't have any conflicts, and you block all transaction commits when this barrier is being run among the whole cluster. When running this PITR, you use something called the recovery target barrier inside recovery.conf, and you can restart your nodes, and your nodes will recover, like I would say a normal PostgreSQL instance, but with this additional mechanism to the point of this barrier. Questions on that? Yes?
Specify time for, that grade barrier gets pretty rough in terms of having to coordinate that amongst everybody.
Yeah.
Everybody commits at one time. Is there a way to say, okay, I give up on waiting for something and either have the grade barrier return as a failure, or have the grade barrier be able to forcibly cancel transactions that are taking too long in order to make the barrier happen?
If during a barrier run you get an error, the barrier will return an error directly. So you won't be able to create the barrier, I think.
Well, what I'm saying, right now it's like grade barrier taken like wait. If it blocks, it waits until that's done before it returns.
Yeah, it blocks, yeah.
Yeah. So I want to bound that in the length of time that I'm holding up all transactions.
So yeah, maybe we need kind of a demonstrate kind of thing.
Right.
We don't have to. Yeah.
Ah, yeah, that's true. Yeah, I forgot.
So please note that this barrier is not generated in all way. So yeah.
Yeah, indeed, I completely forgot about that. One of the current limitations with barrier is that we don't have such a timeout option, such as to say, I want to wait 10 seconds for that. But I mean, it was in the design, but we didn't take the time to implement that fully. But yeah, that's true. I completely forgot about that. Yeah. Yes.
So if I don't do this external way to create barrier, there's not a fault here.
Yeah. If you don't, you have to use this barrier mechanism to return your database to a consistent state globally.
You have to do it while the operation to be able to
Yeah, you need that. I mean, point-in-time recovery now in PostgreSQL is based on the timestamp and on the transaction ID. But with the structure of XC, you are not sure that the last transaction ID of one node has been used on another one, and also the timeline of a node is different from, the timeline is different among the nodes. So you have to use this one if you want to have a correct point-in-time recovery. Of course, you can play with PITR in XC. I wish you good luck if you want to use a recovery.conf file. Of course. Okay, so here is about HA features. So what about the project status? So what have we accomplished up to now, and what are we going to do next? Now XC has been released in, when was it? In June, last June, with the version 0.9.5. We support major DDL and DML. Coity, who is here, counted that we support 88% of the SQL being used in PostgreSQL, as XC uses the same interface as PostgreSQL, except for create table, because, you need that. So if you have an application, you may need some design to make it suited for a certain distribution for a primary key or something like this. But for the DDL or the DML queries or even select queries, we support it the same way as PostgreSQL. We also added some stuff to make prepare, execute queries running correctly. I think we'll do also some push down of prepared queries to be able to execute down prepared plan on a certain data node. I don't really know fully about that, but there is such mechanism. We also support fully session parameters, local parameters, set. You can set a timestamp inside a session. Also we added support for additional distribution types, such as the first releases of XC were only doing distribution by hash using integers. We added types such as also weird stuff such as on timestamp, real. It's very scary, but we added a lot of things to do that. Also, one point is that when you run a simple create table query without using the extension, XC will pick up the first column it can use for hash and will use this column for the hash. So still the normal DDL can work correctly in this case. We also have some support for cursors, no backward cursors, only forward cursors, and current off does not look to work correctly these days. Also, we have support for the major clauses used in select queries, such as having, group by, order by, limit, offset, and a lot of things, but those are the major ones. We have also support for aggregate functions, such as average. For average, what you do is to take the sum. You take the sum of all the nodes, you bring back the sum of those elements on the data node, and you do an average based on the element you got. For a max, it's even a little bit more simpler, min also. But there are such mechanisms being used in XC. Yes, so about the next release, 0.9.6. The plan of this release is the end of this month. What we are going to add in this release is support for temporary objects. By temporary objects, I mean temporary sequences, temporary tables. I just showed you that before. Temporary views, and so everything like this. the code has been merged with PostgreSQL 9.1. What we do is that we wait that the 9.x stable branch is created, and we merge up to the to the intersection point of this stable branch and the master branch, such as we can do at will fork with a certain branch or another one, such as for the release 0.9.6. What is going to happen is that we are going to merge the current XC master branch with the 9.1 stable branch of PostgreSQL to ensure that we don't have the bugs of PostgreSQL inside what we do. We also extend the support for prepared and execute with parameters. We do a smarter push down of parameters for that. I noticed that when you try to create a table using an execute sentence, this was not working yet. Having also has been added now, we added some mechanism to do some having push down to the nodes, to the data nodes. Aggregates also are generally operational. We found a couple of bugs related to that, but those ones have been fixed. And what we do since January this year is that we began to run regression tests of PostgreSQL. We added some regression tests of related to XC, such as when we check some, I don't know, joins between some tables or things like this, or materialization or coordinator, things like this. We added some tests and we run the same tests. We got, for the time being, 75% of the tests running correctly with XC. So yeah, here it is for the time being. So then, we are currently heading for 1.0. For the time being, we target 1.0 for next year in March. And in 1.0, what we are planning to add is support for subqueries, such as with clauses. It also would be nice to support, we don't support yet the use of non-immutable functions in default values, such as for serial or things like this. It would be nice to have such a support. We are currently working on that. Some support is planned to be added for create as, select into. If it is possible, triggers, rules. I'm not sure if we will have time to work on that. This is a little bit more complicated as this operation is cluster-wide, but we got some design done for triggers. Also, return back some support for current off and save point if it's possible. Also, we need a special extension for table space, which is in the case where you have several data nodes running in the same server. If you create a table space, this table space, the same table space will be used for both data nodes. So we need a special extension to say, okay, for this node we need this place, for this other data node we need such a space or things like this. We are aware of that, but this is not a high priority for the moment. If you run data nodes on separate servers, this will work, but if you use it and if it crashes, just don't complain. For the time being, we don't officially support that. So this is for the SQL support. Then related to other mechanisms which are cluster-wide. Oh, I still just got a couple of minutes. So currently, XC has limitation regarding when you try to update the distribution column of a table. You can't update that for the time being because it means that you have to move one table from one node to this other node. We are currently thinking about a way to do that smartly using, for tuple relocation. We are currently trying to design that. This is a little bit complicated, and if we have time, I hope this will be done for 1.0. Also, we are working on an extension to support the data of tables among a subset of nodes, and also some additional mechanism to be able to do an alter table to change a distribution type of a table, and also to change a list of subset of nodes. This is one of the key features if we want in the future to have the possibility to add or to remove nodes. Also, before I was studying about using slave data nodes with master data nodes, so it is possible to create a kind of mechanism which would be a load balancing for read and write transaction among slave data nodes and master data nodes. And okay, and also now the configuration of XC is a little bit heavy, so we are going to use a simplified interface based on SQL, a kind of DDL type SQL to create nodes, to change those node information, and also extension of PostgreSQL catalog tables for XC containing node information to interact with everything about that. So I hope this will really simplify the current configuration file of the current configuration of XC, and yeah, so this is what we are going to. So after 9.1, we got also a couple of huge challenges, which are first the global constraints. You need to do that in a cluster-wide way with a unique reference integrity among a partition, something a little bit crazy, and it's very huge. We also would need global constraints for the exclusion constraints among partitions, so we need to be sure that constraints are checked globally among the whole cluster. I'm not very familiar with such mechanisms yet, but this is currently not the priority for 9.1, but we will do that a little bit after. Then what will be possible is to create a kind of global deadlock detection, a wait for graph mechanism for your cluster to be able to detect deadlocks and things like this in your whole cluster. For the time being, we trick on that. We use statement timeouts to avoid deadlocks inside the cluster. Also, online server removal addition, which is a key point for the for cluster operations, and also some support for SQL-made mechanisms such as foreign data wrappers and things like this. So this is XC, but what could we do for PostgreSQL community? We got a couple of features we could use even inside PostgreSQL, such as this year at PGCon in May, people were very interested about a feature called snapshot cloning. Snapshot cloning is the possibility to share the same snapshot among multiple sessions in PostgreSQL server. This could be very useful for a parallel pgdump, such as you could run a pgdump on several backends at the same time, and you will get the same data view for your dump. Then also, we have some mechanism for parallel query execution. We could also do some SQL-made improvements, such as column projection, join pushdown, order by group by pushdown aggregates. I saw, but I think still this join pushdown is a little bit late. I saw a couple of days before a patch from Shigeru Hanada to support the join pushdown inside SQL-made. And so also the foreign expression pushdown, such as evaluate such functionalities inside data nodes or things like this. We could do also some stuff for the materialization of data on a node from a remote node. We got some special mechanisms inside XC, and we could also do some stuff regarding cross-node joins, such as when you want to perform joins between several remote nodes or even cross-node aggregations or things like this. This is a little bit late for 9.2, but we may be able to submit a couple of patches for 9.3 next year. Okay, so about the project resources and contacts. Just tell me if I'm late. Am I late? No? Okay, so I'm just going just quick on that. So the project page is here. You can use the developer mailing list on SourceForge to contact us if you find things, if you have questions or anything like this. The slides are, you can also use those two contacts, myself and Koichi, who is here. If you have any questions about the projects, ideas, if you find bugs, I don't know what, but if you have any remarks or things like this, everything is welcome, and we will be pleased to answer such requests on that. You can also follow me on Twitter. I do a lot of PostgreSQL stuff, XC stuff, and also I got a blog where I put my PostgreSQL stuff. So this project is supported by Enterprise EB and NTT. And if you got any questions, yes?
Have you looked at the SI reblocks used for predicate blocking for the serializable?
Not yet. Haven't looked at that.
I believe there will be no serious program support. Okay. But I have that, but still, as a kind of fail. Well, I finally do some for that. But I believe there are no problems with that. So it has nothing to do with GTM, with the shiny, with the nutshell. So the exercise can be
Yeah, in May I saw a presentation regarding this new SI and real serializable isolation control, and just by having a look at the presentation, I thought, oh, for XC it shouldn't be. I didn't really think we would need any extensions or things like this, but we haven't checked anything on that yet inside XC. Yes?
Does that mean that if it makes sense that if a transaction rolls back due to conflict or whatever on any of the data nodes, that's going to roll back to...
Yes, on all the data nodes, yes.
Okay.
And even, let's imagine you do a prepare. If you get a prepare and you fail also at prepare state, you get the results, and what you do is roll back stuff on all the data nodes also. If you get an error, I don't know, for what, such as a conflict, or you got a lock on a table being dropped, and you got an error timeout on one of the nodes or things like this, you will roll back everything on all the nodes. Yeah. Any other questions? Okay, so it looks that we are done. So thanks for your attention, and see you on the Postgres XC mailing list. Thanks.